Hello, my name is Jeroen Kroon. I'm going to present you the future of IoT security, a presentation which will explain my point of view when it comes to the information security slash cybersecurity threats to IoT world. I'm a part-time teacher also on the Amsterdam University of Applied Science and a senior manager in security. And all the things I'm presenting here are based on my own experience and information that I worked out for my students. First of all, let's set the scene. Cyber attack caused a lot of business, as we all know. And we discovered that more and more IoT devices are going to be connected to our homes. In 2020, Cisco have forecast that more than 22 billion devices will be connected, and I think it will even grow. But that means that a lot of vulnerabilities are identified, and especially on IoT, it's a quite new world, and therefore we need to make some proper steps. We learn from the past, look in the future, but live in the present. So also the existing situation needs to be protected. First of all, what is IoT? Because to make things clear, it's a quite broad definition, but IoT, that is everything that's connect to the internet, but more machine to machine devices that not like a phone that we are using, but more smart devices. And of course, the Internet of Things is making our life easier, but on the other hand, it's connected to a lot of other things in the cloud, big data, analytics, so make it quite vulnerable for a lot of data attacks. What are the different, let's say, IoT families we can define? So the well-known is especially in our households, like smart thermostats, televisions, like connected frigidairs. The next step is more also in the enterprise environment where we're using IoT in building management systems, like sensors, ventilation, but also elevators, all this kind of devices that can send out kind of preventive maintenance information, but also monitoring alerts. Of course, something that we already know in the past, what we call SCADA in manufacturing, but it's now we can use the word IoT for industrial and control systems. Medical and hospital equipment, of course, more and more devices are connected to the internet. Previously, it was maybe not named as IoT, but we can really consider them as high-end, expensive IoT devices. In transport, but also in retail, we have more and more applications where devices or computers with specific functions are fulfilling IoT roles. So in general, how are IoT devices communicating? Because this is giving a lot of impact on the security picture. Most of the IoT devices are connected wireless, and different protocols or technologies are used, like the Wi-Fi, but also local wireless network using Zigbee, Bluetooth, Z-Wave, and other new protocols, which are not traditional in their foundation properly secured. Of course, NFC and mobile like G3, G4, like smart meters are all different ways to communicate, in fact, to the backbone. And still, we have, of course, wired devices using the normal Ethernet cabling systems. Some interesting things is, for example, smart toys, because this kind of equipment is using more and more geolocation interaction with minors, underage people, and a lot of vulnerabilities have been seen here. And not knowing that the manufacturers, when they created their, as an example, we have also smart toys, devices that have been manufactured, but not always taking in consideration the risk they are giving, especially to underage people, because in the design, not everything has been fully checked, especially when it comes to geolocation, taking over the cameras. So a lot of examples exist in the last 2 years where different vendors have been placed in public news with faulty devices. Medical devices, of course, uh, from leisure, like running toys, but also life critical devices mean the importance to have these protected is very important. And normally, when this equipment have been designed, not always the secure by design principles have been followed in their initial build versions. If we look at the growth, these are some forecast figures, especially when we take the first slide from Cisco. But we can expect in about 10 years or later, we will reach more than 100 billion devices in the internet. This is something nobody has forecasted, but also all the existing technology that we have to manage networks are not suitable for this large scale kind of networks. Of course, we could consider not using IoT, but there's also very good benefits. So improved outcomes, access to real-time information, customer service, healthcare benefits, but also the enhanced experience as consumers. So therefore, IoT makes our life better. So it's not like, oh, it's insecure, so we're not going to use it. But I think, yeah, IoT is going to be part of our daily life. So it's better to embrace it and make sure that we make things secure instead of denying it. So the promises of the Internet of Things are great. When we're talking about smart city, smart government, a lot of things that we can use connected from the only moment we ensure it's secure. Because we will see it from cars, energy, smart homes. And there's some the good benefits of that. If we go to some present facts, if we look at, for example, our new home, including my own home, we have different devices that we can manage, like the light control, but of course our TV connected to gateway, our Wi-Fi, and we are looking more and more to energy management, also some safety protections, motion. In my case, when I am approaching 2 kilometers or 2 miles from my home, automatically the heating is going a little bit on to make it comfort when I'm arriving home. All this is possible. The same when I'm leaving home, I'm checking if everybody left home. In that case, lights goes off, which spares me money, but also create a better climate for everybody worldwide. So yeah, but in this case, we will have a lot of devices connected using different protocols because not all the technologies are fully operational and interoperability between themselves. So what are the threats coming up? A lot. So we see car scamming, the smart toys, TVs, uh, because so many different systems means so many different software layers writing codes, and which create a lot of vulnerabilities and opportunities for hackers to get in. So how to solve that? Now, in order to understand, let's split a little bit piece by piece. What's the IoT? IoT has a lot of, I will say facing things, but the attack targets exist on the different industries. So first of all, every, I will say, major provider or vendor have been hit in this part. So depending on which domain, which area, transportation, finance, attacks exist. So that's something we need to accept. And from that moment, we know the risk and we know how to protect it. We can make the following steps. The IT device landscape is very fragmented. There are a lot of vendors providing sub-solutions and based on specific operating systems. This is one of the biggest challenges we have in the information security industry because there's a general lack of industry standards. And like ISO, there is not a generic global approach yet for IoT security. And that's what we are all facing today. Also, the IoT creates a much bigger attack surface. because we're connecting so much more devices to our networks, including our corporate networks. Yeah, it's opening the door for vulnerabilities and attacks. And let's see in the next slide how people can succeed to get in IoT devices. So where are the vulnerabilities? It's based on the different functions that we are doing using the IoT. So to explain, there are 9, say, main IoT functions. Upgrading, pairing, the binding, the authentication and control, the remote authentication and control, and the link to the big data and notification. All these different functions have their, I will say, gaps and challenges. And let's go in detail because this is where the improvement need to be done to have a full secured IoT future. Upgrading. IoT upgrading is a specific element of IoT security because IoT devices are using specialized firmware and a lot of different software stacks, uh, from 20, 30 to hundreds of that. Some are part of open source, some are not. It needs a lot of testing. So the security challenge we have is that not all components or all vendors are able to provide all the security, I would say, checks, certifications for the different libraries or software components they are shipping to the vendor to create the IT device. Also, some vendors start to be obsolete, so that when you're building your device with software and hardware, after 2 or 3 years, some components are not available anymore and need to be replaced. This creates, especially what we have seen in the past using SCADA, some dangerous vulnerabilities that we know on legacy systems. So that's very important to take in account that upgrading and maintaining the software stacks on IT devices is a very basic function to fulfill correctly. Because what are the specific challenges? First of all, the IoTs are in general limited memory and function because they're embedded devices, and most of the devices are designed for consumer market. Mean price is an important reason when they are building architecture. So this taking in account, it is always a challenge between price and functionality. The other step is the pairing and binding. In order to have the device connected, using these sometimes less secure protocols like Wi-Fi, Zigbee, NFC, it creates challenges but also vulnerabilities because we need to store somewhere some Wi-Fi passwords or local information. With the, I would say, improper coding or secure controls, this creates huge weaknesses in the systems. The next is also the local authentication and control. In order to control the IoT devices using, for example, the tablet or your mobile phone, depending the credentials and the policies the vendor is implementing, in order to get simple access, if the password length is just 2 characters or 4, that means yeah, low credentials implementations, and this is again not very secure. The other element is also the remote notification and control. Of course, we want to access um, from our mobile phone, for example, or our computer outside when we are on work, devices at home. This goes to the network and mean that access needs to be opened on our home network using address transformation, but also changing some settings. This is quite complex for most users. And with the improper settings or defaults that are often used by your own internet hosting provider or telecom communication provider, this creates huge gaps. The next tab is also the data security that helps now to make the communication secure. But this is really depending on the vendor, how they implement the different transport and layer encryptions. And that creates, again, also complexity of the PKI management. You need to store private keys and change and update. How is this managed properly using the vendor or some cloud solutions? Again, this is here still a large challenge for IoT solutions in general. The big data, of course, our IoT devices are giving information, valuable information that vendors can use to improve their service, but also in a couple of cases resell this information. How are the different things completely closed or in line with the new GDPR rules or other data privacy regulations? Especially when we are buying toys from China. Big questions. And this is also an area where IoT is very immature at this stage. So the large challenges is also the amount of data. Don't forget, some research is done and that we are going to exceed 100 zettabytes in 2020 and data on IoT devices. Um, and a general rule, how more data we have, how bigger the risk for data theft, right? So not only the IoT devices need to be protected, but also the data that we're going to store somewhere. And as last, the sensing notification. Well, all IoT devices are giving events alerts. How to deal with that? So the correlation from abnormal behavior or security events need to be managed through vendors or independent platforms. We are used to classic network solutions like SIM, Security Incident Event Management tools, but they have all be written or adapted for enterprise networks, not for millions of devices like in IoT. So this is again a challenge for the existing vendors in that space. Privacy and the Internet of Things. As we know, IoT devices are very often used for home consumer purposes. This means a lot of personal information is handled through the IoT device components. As we know, address, geolocation, a lot of this data is going through the IoT device itself, but also in the systems in the backend, like the data collection service, or also on the ability to remotely control. It's not always very clear how the vendor or the service provider is properly managing on this data and has the correct policies in place to help you to understand which of my data is properly handled or not, especially when we take it in account with the new regulations like GDPR, that all this data need to be agreed before you're using the device by consent, and also in case of data leakage or data theft, how the vendor is acting on that. So think about a cheaper IoT device that maybe you are buying from China. Um, how is that handled? Good question. To end the presentation is what we can do at this stage to protect in the future of our IoT. First of all, policies. We need to be much more defining the guidelines and the policies. So privacy by design, doing threat assessment, threat modeling when we are building new IoT devices, so that really the vendor from the beginning is taking security and privacy by default. The next step is about organization and the end of life support, the vulnerability, all the third party relationship. Don't forget, most IoT devices are working with other IoT devices. So how is that handled when some product is faulty? against the others. And technical, based on the different parts we have seen previously, on the trust and integrity, but also the data protection, the update, all the different components, cryptography that we need to ensure proper secure communication and encryption of data on the device itself, the logging. So all these things need to be more defined and as best practice. So not discovering that some IT devices are not secure. So therefore, based on my experience, I will suggest the following IoT recommendations. First of all is harmonize the security initiatives by government or using organizations like EC Council also. Awareness of the needs. Again, awareness, education is very important. The software and hardware development lifecycle, secure by design. When designing and building and creating software or hardware, the security should be from the beginning. Interoperability, that's another challenge. Open standards, but well-defined standards should be the next steps. Economic and incentive. We have already some things going on, like GDPR, where we can get fined for data leakage, but it should be more common for all IoT security. And I think the liability for the IoT stakeholders, so that people are very responsible for the solution they put on the market. Thanks for listening. Hereby ends my presentation.